Hi, welcome to the discussions on the solutions of the JEE main papers. In this segment, we shall take up the physics part of the paper which was conducted on the 6th September in the evening slot. Let's start with question number 1. Question 1 says, a circuit to verify Ohm's law uses ammeter and voltmeter in series or parallel connected correctly to the resistor. In the circuit, the first option says ammeter is always connected in series and voltmeter in parallel. The second option says both ammeter and voltmeter must be connected in parallel. Third option says ammeter is always used in parallel and voltmeter in series, and the fourth one says both ammeter and voltmeter must be connected in series. Now, it is a pretty straightforward question. The topic is experimental physics. It is also related to current electricity clearly. The current which is flowing in a resistor or in an element is to be measured by the ammeter. Ammeter must be connected in series because it has to measure the current flowing in that particular path. Whereas, the voltmeter is supposed to measure the potential difference between 2 points, and it has to be connected across those 2 points. So, that means the voltmeter must be connected in parallel across the resistor, whereas the ammeter is to be connected in series, which means the first option is the correct one. It says ammeter is always connected in series and voltmeter in parallel. Let us go to question number 2. Question 2 says particle A of mass m1 moving with velocity root 3 I cap plus j cap meter per second collides with another particle B of mass m2 which is at rest initially. Let v1 and v2 be the velocities of particles A and B after collision respectively. If m1 is equal to 2m2 and after collision v1 is given as I cap plus root 3 j cap meter per second, what is the angle between V1 and V2 vectors? Clearly, the question is about collisions, and we can apply the conservation of linear momentum principle here. Let us write the equation which comes from the conservation of linear momentum principle. The momentum initially is m1 multiplied by this velocity. So, conserving linear momentum, we are getting m1 multiplied by root 3 I cap plus j cap, and on the right hand side what do we have? We have m1 v1 vector, but v1 vector in fact is given to us because v1 vector is I cap plus root 3 j cap. So, this is m1 into I cap plus root 3 j cap plus m2. But we see that m2 is in fact equal to m1 by 2. So, let us write it here m1 by 2 for m2 and its velocity which is in fact being called v2 vector. And what are we supposed to find? We are supposed to find the angle between the v1 vector and the v2 vector. Well, let us solve this, and if we solve for v2 by 2, we are getting v2 divided by 2 as in fact root 3 I cap plus j cap minus I cap minus root 3 j cap. That means it is coming out as root 3 minus 1 I cap, and then we have minus of root 3 minus 1 j cap. That is the velocity vector given by v2 divided by 2, that is the expression. Now, what is the angle between these two velocities? v1 is in fact I cap plus root 3 j cap SI units, and the expression for v2 we already have. Now, as far as the direction goes, direction of v2 and direction of v2 divided by 2, basically they are same. Let us show these two vectors in the xy plane, and let us draw the axis. Say this is the x axis and this is the y axis. Now, the first vector, which is I cap plus root 3 j cap, the V1 vector, in fact is making angle of 60 degree with the x axis, and so we can show it something like this. This is the direction of V1 vector. Okay, this particular angle is given as 60 degree clearly, because you know tan theta is coming out as root 3. So, this angle is 60 degree. What about the direction of V2 vector? We can see that the two components, the x and y components, have equal magnitude, but this component is in the negative y axis and this is along the positive x axis. That means this vector is directed at angle 45 degree with the x axis, but it is below the x axis. So, that means the V2 vector we draw at angle of 45 degree with the x axis. We are calling this as the x axis, and this angle is 45 degree. This is the V2 vector. We are not really concerned with the magnitude. We have to find the angle between the two vectors. Clearly, the angle between the two vectors is 60 plus 45 or 105 degree. Let us now look at the options, and clearly the fourth option is matching with our solution. So, fourth option is the correct one. Let us go to question number 3 now. Question 3 says a square loop of side 2A and carrying current I is kept in xz plane with its center at origin. A long wire carrying the same current I is placed parallel to z axis and is passing through point 0, B, 0, where B is very large compared to A. What is the magnitude of torque on the loop about z axis? The four options are given. So, first of all, we note that the square loop has side 2A and it has current I and it lies in the xz plane with its center at the origin. So, let us again depict the situation with the help of a diagram, and let us say that we have x axis like this. This is the y axis and the z axis is in fact coming outward. Okay. So, let us draw the z axis also here. This is the z axis, this is the y axis, and the plane of the loop is in the xz plane. That means we can show it something like this. It goes something like this. Okay. So, let us say this is the plane of the loop, and let us say that the current flowing is I here. Now, we have to find the torque acting on this loop due to a straight current which is in fact passing through point 0, B, 0 and which is parallel to the z axis. So, that means we can show the current as somewhere here it is parallel to the z axis, coming like this. We can imagine that the current is coming outward, and due to this current I, what is the torque acting on the loop? Now, we note that the value of B is given as much larger than A, and that makes our task quite easy. The magnetic field at the center due to this current I, which is flowing along the z axis, we can now write it as mu naught I divided by 2 pi into B. Remember, this distance is B. So, we have the magnetic field as mu naught I divided by 2 pi B. What is the direction of this magnetic field? Well, if the current is flowing like this, then the direction of magnetic field at the center is along the x axis. Since B is very large compared to A, we can take that for the expanse of this particular loop, we can take the magnetic field as uniform directed along the x axis. So, let us write the expression for the magnetic field produced by current I. We have B as mu naught I divided by 2 pi B, and the direction is along the x axis. What about the m vector? Because to find the torque, we need to have m cross B. The m vector is in fact, the square loop has side length 2A. So 4a square is the area, the current is I, and the direction is along j cap. So the m vector is 4a square I, the current, and the direction is j cap. The torque is m cross b. Since the two vectors are mutually perpendicular, so the magnitude of torque is simply the product of these two quantities, and that means the magnitude of torque is now coming out as 4a square I into mu naught I divided by 2 pi b, which further simplifies as 2 mu naught into I square small a square divided by pi into b. Let us now check the options, and if we look at the options, well, we in fact the fourth option is clearly matching with our solution. So, option 4 is the correct option. Let us now go to question number 4.